talk about absolute value. So the absolute value, we're going to talk about something called a parent function, okay? So remember how I told you in Algebra 2, we're going to be learning about a different function for every single unit, right? Unit 1 is absolute value. The parent function is basically your most basic function of that type of, your most basic equation of this type of function, all right? So like for absolute value, what is the most basic form of it? That's your parent function. This is where everything happens. It can stretch, compress, move left, right, up, down. It all happens here, okay? So the equation for the most basic absolute value, your parent function, would be y equals the absolute value of x, right? That's pretty simple, right? And then that space right there next to equation, that's for you guys. That's where you're going to make notes and whatever you need to, all right? Just take notes and put important things there if you like. Okay. So let's graph this. We're going to come up with a table. For the table, I'm going to draw, you guys know this, table of values. We've done this before, right? All right, so the x is the input, y is the output. Do you remember that from functions? Okay, so if I give you a basic equation like this, your parent function for absolute value is y equals the absolute value of x, yeah? Well then, say I did 0 for x. If I plug in a 0 in here for my x, what do I get? What's the absolute value of 0? 0. Well, then I get that for my y. There you go. How about -1? What happens when I plug in -1 for the x? What's the absolute value of -1? 1. How about -2? What's the absolute value of -2? 2. Right? Look at this. You guys are making your own table. 1 and 2. How about those? Positives. 1 and 2. Good. And you know what? Everyone has a calculator, and you guys will always have access to a calculator. So let's take a look. Go to y equals, and let's go to math, tab to the right, to go to number, and then let's hit abs. That's absolute value, right? And then let's put x. If yours comes out as ABS parentheses, that's okay. Put in x and then close your parentheses so that you close the bars. All right? If yours looks like mine with the bars, make sure you hit the right arrow so that you get out of there. Okay? And then we want to go to second graph. You see that? They give you your table right here. Okay? You know what though? How did I know? Like, why did I choose to put 0, 0 right in the middle? I'm going to show you why. Go to graph. Where is your vertex for this graph?
The origin.
At the origin, at 0, 0. Isn't that the vertex right there? That's why. You always put your vertex in the middle, get 2 points above, 2 points below. Okay? All right, so now let's go and graph this. 0, 0, -1, 1, 2, 2, 1, 1, and 2, 2. Okay? Any questions? All right. Now, let's talk about the domain, range, and all these other properties, okay? First of all, for the domain, guys, I want you to put always. Because it doesn't matter what happens to an absolute value function. The domain is always going to be this, okay? Oh, back up for a second. By the way, what can you tell me about this graph? What does it look like? Huh? A B, right? Not even just like a little cursive B. It's a very sharp B, right?
Yeah.
Absolute value graphs always look like a sharp B, okay? So if you ever see a graph like that, you know, oh, that's an absolute value. B for value. Got it, Abner? Okay. So the domain, you have an arrow on the left and you have an arrow on the right. Oh, no, I meant to do, it's okay, we can do this. So that means it's going out all the way to negative infinity. And then look at that, arrow to the right, it means it's going all the way out to where?
Infinity.
Yeah. So you know what? Domain for absolute value is always all real numbers, negative infinity to infinity. Okay, always. There we go. All right. So let's talk about the range. So the range, we always look at it from the bottom to the top, right? Do you guys have any arrows going down to negative infinity? No. So where does this graph start? At 0, and then it keeps going up to where? Infinity. That is your range. 0, because, okay, 0 has a closed circle, so it gets brackets. To infinity. Because it starts at the y number 0. Now, guys, is this continuous? Yes, good. You don't have any holes or gaps or breaks in this graph, right? Okay. So, yes, it's continuous. Let's look at zeros. What do I mean when I say zeros? Remember? It's some kind of intercept. We're talking about the x-intercepts. Okay? Make a note for yourself if you do not remember that. Zeros mean the x-intercept. So where does this graph cross through the x-axis? Cross through or touch the x-axis? At where? Okay, give me the point, all right? So the origin is 0, 0. All right, I want an actual point, so just give me one number, please. How about the y-intercept? Is there a y-intercept? Yeah, Kevin, where? 0, 0. You know what? I love that about the parent function. Parent function for most of these graphs, a lot happens at 0, 0. Now, minimum and maximum. If we have a B, does that have a minimum or does it have a maximum? Hmm?
Minimum but no maximum.
What?
It has a minimum and no maximum.
Good. It has a minimum, right? Because it is down, it's right here. It's like, you know, you have to go down your hill, right? Down the valley. So your minimum is at 0, 0. Is there a maximum? No. If this had a minimum and a maximum, it would look like a diamond, right? No. So now let's talk about increasing, decreasing, and constant, right? You guys already have 2 of your numbers done. right? We also need to draw a line through where this graph changes direction. So it goes down like this, and then look at that, it goes up here. So it kind of changes direction right here. Do you agree? What is the x number that this line goes through?
0, 0.
0. So I'm going to put just the x number, right? So tell me, what is it doing from negative infinity to infinity? What's that doing?
Going down.
Good. It's decreasing. What's it doing from 0 to infinity?
Increasing.
It's increasing. Is there any place on this graph where it goes constant? No. So you know what? For constant, let's write none. And that's another one of those, your absolute value never has a constant interval, okay? Now, where is it increasing? From where to where? Thank you. Always parentheses, right? 0 to infinity. And where is it decreasing?
Negative infinity to 0.
Negative infinity to 0. Good. Now, let's look at the end behaviors. As x approaches negative infinity, if you're on the x-axis and you want to go towards negative infinity, which way do you have to go?
Left.
To the left. So this is talking about the left arm. What is your left arm doing?
Going up.
It's going where?
To negative infinity.
Oh, it's going down to negative infinity?
Going down, yeah.
Is it?
Well, it's going up.
It's going up. So where's that going? To positive. Okay? Alright. Sorry, I'm not trying to call you out, but there's somebody else who's thinking the same thing. I just want you to, you know what I mean? Instead of me just as x approaches infinity. So then this one has to be talking about the right arm, right? Oh no. What is the right arm doing? Wrong one. There we go. It's also going up. It's going up to infinity. Almost messed up the whole thing, didn't I? Are we okay with that? Guys, if absolute value looks like a sharp V, right? If one arm is going up, what is the other one doing? It's also going up. It's going to do the same thing. If it was flipped and they were going like this, if one arm is going down, what is the other one doing? It's going down. Shouldn't they always be doing the same thing? Right? They should. They always should. Or else it wouldn't look like a V anymore, right? If one was going down and the other one was going up, well then now what does it look like? What does that look like? It looks like a line. It doesn't look like an absolute value anymore. Does that make sense?
Yeah.
Absolute value, your end behaviors are doing the same thing. Okay? Alright. So now let's talk about the vertex and the axis of symmetry. What is my vertex here?
0,
0, 0. Okay. Now, what is the axis of symmetry? Have you guys ever heard of that before?
The y.
I heard of symmetry before, like split.
Yeah, right? You've heard of symmetry? Okay. Axis of symmetry is basically where's the line
Splits.
that basically splits this graph into half, symmetrical halves, right? So you already wrote it right here. It was at 0, right? But at what? 1 equals 0. You know I love these math puns, right? These little math joke things. Please remember it's always in the name. Axis of symmetry, X is. Alright? So you have to make sure you write X is. X equals. Okay? X equals, let's write this down. X number from your vertex. Okay? X equals, just get the X number from your vertex. So for this one, it would be X equals 0. Axis of symmetry, X is. Okay? It is an equation. You have to tell me x equals. Questions? All right. Let's try some more. You guys have a couple. You have a couple problems on the bottom there. Let's find the vertex and the axis of symmetry. What's the vertex here? 3, what? 3, 1. Good. To the right, 3 up 1. 3, 1. So what is the axis of symmetry? What is 3?
3, 1.
X equals 3. Thank you. I'm going to be super picky about that, guys. I'm sorry. Warning you right now. How about the next one? Oh, this one reflected, right? This one flipped. It's not a V anymore, it's a caret. But that's okay. It's still an absolute value. What is the vertex? Negative 2 to the left 2 up 3. So negative 2, 3. Good. And what is my axis of symmetry? X equals negative 2. Good. Remember, I want the X number from your vertex. How is it so far? Pretty good? All right. Okay. All right, so let's look up at the top. Guys, the standard form of these absolute value functions is written there for you. And just by looking at this, we can talk about how this graph moved or changed from the parent function, okay? And remember, the parent function was just this guy, right? So look at all these different things that were added on, okay? So I like to start from this, the plus k on the outside. We've talked about transformations. What happens when you have a plus k on the outside?
You subtract okay.
Well, tell me in words, how does it move? Huh? Up k. Great job. If I have a plus 2, that means it went up 2. What about if I have a minus k then? Oh, no, minus k.
Down K.
Down k. Sorry, Ethan, you're ahead of me. Okay? Now, let's talk about this guy right here, x minus h. If I have x minus h, that moves it how? Anyone remember? Huh? Right, good. Right h. Good job. It's kind of like the opposite, right? Because you want to say left because it's minus, but no, it's right. When it's inside the grouping symbol with the x. So then if it's x plus h, it has to move left h. Good. So then let's talk about the next change here, the a. There's going to be something in the front, right? The a. So, yeah, here's the thing. If you have a negative in the front, what happened to it? It flipped. It flipped. It flips or it reflects. Right, both. But how about if they give you a number that's bigger than 1 in the front? Did it stretch it or did it compress it? What do you think? Stretched it. Good. If that number is bigger than 1, then it stretches. But if you have a number that's bigger than 1, I'm sorry, bigger than 0 and less than 1, so like 1/2, 1/3, 5, 6, right? Then this compresses it. Okay? Questions? something, you can look at the equation and you can give me the vertex right away. All right? There are a few ways to think about this. You could actually think about the graph moving according to the transformations, or you can use this trick. Your x number is going to be opposite whatever the number is that's inside with the x. That gives you your x number, opposite h. Your y number comes from just plain old k on the outside. Don't do the opposite for the k. It's just whatever k is, okay? And of course, the axis of symmetry is x equals the x number from your vertex, right? So with these, okay, let's talk about the transformation, and then let's get the vertex and the axis of symmetry. So remember, your parent function is y equals the absolute value of x. What kind of things happened here, right? What was added on here from the most basic form of that function? I have a +1 on the outside. What else do you see? Yeah, that +5 inside, right? So what are my transformations? Left 5 and up 1. Great job. Does everyone see that? Okay, so what is my vertex? What is the opposite of the number inside with the x? Huh? -5. Right now, the number inside is +5, right? Opposite would be -5. And then what's my k number? Number on the outside? 1. So there you go. That's your vertex. Okay? So what is my axis of symmetry? X equals -5. Good. Do we agree? All right. Let's try the next one. So the next one has, okay, oh, it has this 3 in front, and it has this -4 on the outside. Somebody give me a transformation, just one. Down 4 and what? Stretches. Good. Down 4. And there's a stretch. Okay. Now, what is my vertex? Let's see. Opposite the number inside with the x. Hold on. Is there a number inside the bars with the x? No. So then what number do I have to put? What's something? What is nothing? 0. Okay? Because I'm talking about x plus something, right? And it's nothing, so it's x plus 0. What is my k number on the outside? -4. So this is your vertex. 0, -4. Yes. Axis of symmetry is x equals 0. Good. Now let's look at the next one. So the next one is a little bit, you've got to be a little bit careful here. There's a negative and there's a 1/2. It's not -1/2. It's a -1 times a 1/2. They have two separate jobs, okay? Yeah. So it flips, and then what does a 1/2 do? Good. So the negative tells me that it flips or it reflects. Right? The 1/2 tells me that it compresses. That x minus 1 tells me right 1. Good. And then that +3 on the outside tells me now Now, who wants to have a go at the vertex? Everyone, you want to hear what Ethan? It's always Ethan. Why? Okay, Ethan, tell me. 1 comma what? Do we agree? Is it 1 comma 3? Yeah. Okay. So if you're not sure, let's see. Ethan, tell me, where did you get the 1? Okay, so right in here. Okay, the number that's with the X right now, what is it? What's the opposite of -1? Okay, that's where that came from. Thank you. Where did you get your Y number from? The outside, the +3. And do we need to do the opposite? No. Okay. So now, what's my axis of symmetry? Axis of symmetry. X equals 1. All right. Listen, I know it's cheesy, but if it helps you remember, better not get that wrong.
Well, that's the symmetry.
Oh, you mean for the vertex?
Yeah.
Because, okay, that's a really good question. Your parent function was right here at 0, 0, right? Okay. If it moves right 1 up 3, right 1. Uh-oh. Oh no, what happened? They all moves right 1 up 3. Say right there, right? If I were to stretch this or compress it, does it affect the vertex? Like if it were to go like this, or if it were to go like that, does it affect the vertex? No, it just changes like, kind of like the width of the bead. Okay? So that's why it doesn't affect it. That's a really good question though. Does that make sense? Alright, so let's go on to the next one. Okay, now we're going to name the transformations and write the equation. I'm so glad you asked that question because this is basically what I just did, right? Your parent function, remember on the first page, where was the vertex for your parent function? Your most basic.
0.
0, 0, right?
Yeah.
We said everything happened at 0, 0. And then it was like this, right? Okay. So now think about this, guys. How did it go from the parent function to this blue graph? How did it move? To the right 4. Does everyone see that? Now, how do I write that equation? Let's see. I know I have a y equals because it is an equation. Okay, don't forget absolute value because this is a sharp B. This is absolute value. X, and you said what? It's -4. Does anything need to go on the outside? Did it move up or down? And it didn't flip. It didn't stretch it. It didn't, it didn't make it narrower. It didn't make it wider. So good. That's it. That's all you're doing. Okay? Timon, you okay with that?
Yeah.
All right, let's try the next one. Ooh, what happened here? Yeah.
It reflected and it moved up 5.
Look at this. It flipped. Because remember, your parent function was a B, right? But this guy is a caret. So, oh my goodness, it reflected. Or it flipped. Now, your vertex just know what I mean? Like it went up how many?
5.
5. Good. It went up 5 and it flipped it, so that's why that happened. Yeah? You see that? So now, let's think about this. Y equals, I know I have an absolute value with the x. How do I show reflex? Negative? Negative where?
For the absolute value.
Good. The negative always has to go in the front. Do I need to put in a number inside with the x? Did it move left or right? No. Okay, so I'm going to close it there. How do I show up 5? Plus 5 on the outside. Good. There you go. That's how you do that one. Okay? So now, guys, this is putting it all together. You guys are doing such a great job. Now this is where we're headed. Okay? So we're going to look at y equals the absolute value of x plus 4. Let's talk about the transformations. This guy is the only, it's the only thing that happened, right? The only thing that got added on to the parent function. So, how did that make it move? Up 4. Good. Now, what is the domain always? What did I tell you the domain is always for absolute value? Yeah, all real numbers, negative infinity to infinity, always. I don't care if it's stretch, compress, reflect. Domain is always negative infinity to infinity because you have an arrow on the left and an arrow on the right. Yes? Now, tell me, what else can we figure out? How about the vertex? What is the number that's inside with the x? 0, because there is no number. 0, comma, what's the number on the outside? 4. So 0, comma 4, that's your vertex. If you still don't understand how to get the vertex, don't worry. We can put this in the calculator and you'll see where the vertex is too, okay? Now, since I know the vertex, what's my axis of symmetry? X equals 0, good. Oh my goodness, look at that. 4 already, and we didn't even graph it, right? So now let's go in our calculator, and we're going to put in y equals, we're going to put in absolute value of x plus 4. So I'm going to go back to y equals, put in math, number, abs. If you get parentheses, that's okay. That means your bar started. You're going to put in x. X is right next to the green alpha key. And then you close your parentheses, or if yours looks like mine, just hit the right arrow and get out of there. Okay? Now on the outside, what else do we have? Plus what? Plus 4, so plus 4. Yes? Now, let's graph it. Let's take a look at where this vertex is. There we are. Okay? If you don't remember opposite HK,
We got like 4.
yeah, it's a 0, 4,
Yeah.
right?
Yeah.
Good. So if you don't remember how to do that trick that I showed you, graph it, right? Now, I'm going to go to second graph. Let's go to the table. Go and highlight where your vertex is. If you can't really tell where your vertex is on your graph, you can certainly find it on your table. Because look at this. Guys, what happens to the y numbers?
Yeah.
Aren't they the same?
Yeah.
On both sides? So the one in the middle, that's your vertex. So 0, 4, and then it goes 5 on both sides, 6 on both sides, 7 on both sides, right? Because it's symmetrical. Does that make sense? Yeah? All right, so let's copy this table down. I'm going to go back. I'm going to put 0, 4 right in the middle. that have 1, 2, and -1 and -2, right? And we said what? They were, because we want 2 points above and 2 points below our vertex. And we said the y's were what, 5 and 6? Yeah? Okay, and then let's graph it. Some of you guys are ahead of me. Good. Graph. Okay. So when you're done graphing, just look up. So now let's talk about the range. So we start from the bottom and we work our way up. Where does my graph start? At 4. Good. So at 4, I have to put a bracket because that's a closed circle. And then it keeps going up, 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 up to where?
Infinity.
To infinity, because I have the arrows going up, right? Infinity always gets a parentheses. Oh no. Oh no, my comma looks really funny. Let me just make that one over. There we go. Now, let's talk about something else. How about zeros? Are there any zeros? What do I mean by zeros? Huh? What do I mean by zeros? Go look on your front page. X-intercepts, thank you. Do I have any x-intercepts? No, the graph is so far away. It's never going to touch the x-axis, right? So this is none. Now tell me, guys, does this have a maximum or does this have a minimum? Maximum, so it's up at the top. It's down at the bottom, so that's a minimum, okay? Remember, maximum would be like up at the top of the carrot, okay? So maximum, we can write none. Minimum is at what point? 0, 4, right? Remember, you gotta give me the actual point. Now let's go knock out another easy one. How about y-intercept? Where does this graph cross through or touch the y-axis? Right there at 0, 4, right? Good. All right, so let's see, what else? What else do you want to do now? Increasing and decreasing? Okay. So, I have an arrow on the left. Where's that going? Negative infinity. I have an arrow on the right. Where's that going?
Infinity.
Infinity. Where's your axis of symmetry? X equals 0, right? Because look, that's where this graph changes direction, right here. So I'm going to draw a line through. That's my axis of symmetry, right? And that's at x equals 0, right? Do you agree? Okay. What is this graph doing from negative infinity to 0? What's this doing?
Slowly decreasing.
It's decreasing, right? From the left to the right. What is this graph doing from 0 to infinity?
Decreasing.
Increasing. Good. So there you go. You have your intervals. And remember, increasing and decreasing, they always use parentheses. Good. Thanks, guys. You're doing an amazing job. All right, how about my end behaviors? As x approaches negative infinity, what's my left arm doing?
Increasing.
Okay, it's going up, right?
Yeah.
Good. It is. It's increasing. The y values are increasing. Good job. So what did I say? If the left arm is going up, what's the right arm doing? It's also going up. Good. And you can tell right over there. You can look at the graph. The right arm is going up, right? Okay. Pretty good. You want to try the next one? Let's do this. Uh-oh, reflex. I see the reflex. How did I know?
Negative in the front.
Yeah, that negative in the front. Good. So I have the negative in the front. I have a plus 6 inside with the x, and I have a minus 3 at the end. I already told you one. I said reflex. Can somebody else give me another transformation?
It would go up 3.
Uh-oh. Down 3. And what'd you say, Sabrina? Oh, you said down 3? Then how about the x plus 6? How does that?
Left 6, yeah.
Left 6. No, stretch would be out in the front. What else do I know? Right away. What can we fill in? Oh, okay. I'm not even there yet. Oh my goodness. Hold on. I meant domain. What's the domain? Negative infinity to? Good. And Ethan, you're right. That is the axis of symmetry. Okay, wait, hold on. You want to do the vertex? Perfect. Let's do it. What is the number that's inside with the x? What's the opposite?
Negative 6.
A negative 6. What's my k number on the outside? Negative 3. Don't do the opposite for your k number. Ethan, did you say 3 or negative 3? Uh-oh. Negative 3. So now that we know the vertex, what's my axis of symmetry? Good. X equals negative 6. And Ethan was so ahead of us. He said x equals negative 6. Way before I even found the vertex. So good. Just make sure you, the y number doesn't do that. All right. So, okay, let's go graph it. I know my vertex, so that's the number that's going to go right in the middle. Right? And then I want to get two numbers that are above it and two numbers that are below it. So let's see, negative. Okay, let's go graph it. Gotta put negative, don't put minus, you gotta put the negative. Math, number, apps, x plus 6, and then close your parentheses or get out of the bars. And then do, was it minus 3? Alright. Your graph should look like mine. If it does not, then please say something. I'll come around and look. Okay, so now I'm going to go to second graph, right? And I'm going to go to where my vertex is. What is that? Negative 6, negative 3. I'm going to take the two numbers above and the two numbers below. All right? And let's write it on our table. So I have negative 7, negative 8, negative 5, and negative 4. Yes? So when my x is negative 7, what's my y? Negative 4? And then that's telling me this is also negative 4, right? Negative 8, negative 5. So then this is also negative 5 because absolute value is symmetrical, right? Okay, let's graph it. Negative 6, negative 3. Negative 7, negative 4. 8, negative 5. Oh my goodness, how pretty. Yeah? When you guys are done graphing, just look up. Okay, so let's talk about something easy. Do you see any zeros here? Yeah? Somebody tell me, no, somebody tell Abner. What do I mean by zeros? Excellent, you already know. Why'd you tell me yes? Does this graph cross through or touch the x-axis? No, it's too far down. So that one is going to be a none. So now, Sabrina, I'm going to ask you this one, okay? Does this have a maximum or a minimum? And where is that maximum? Give me the actual point. -6. And what? It's going to be the same as the vertex. Okay? -6, -3. So, since Sabrina told us that there is a maximum at -6, -3, is there a minimum?
No.
No. You can't have both. You can only have one or the other, right? Now. Oh, okay. Range. Let's do the range. Remember, we start from the bottom. But wait a minute. These arrows go down. Where are they going? Negative infinity. So this actually starts at negative infinity because it goes all the way down, right? And then where does this graph end? Everyone see that? Where does it end? What y number? -3. Okay? Does that make sense? All right, so the y-intercepts. Here's the thing. You know what? This is going to keep going. It crosses somewhere here. But you know what? You have your calculators. I'm going to show you a little calculator trick to get the y-intercept. You want to go back to your calculator and go to graph. You still have the same one up, right? Okay, everyone go to calculator, hit graph. Now, hit trace. You see up here at the top, you see trace? Yeah, hit it. It's 0. You see how it says x equals 0? Hit enter. What does it tell you? So there you go. Your y-intercept is 0, -9. Your calculator will always tell you the y-intercept this way. So make a note for yourself. Graph, trace, 0, enter. That tells you the y-intercept. Okay? Now, about the increasing and decreasing intervals. Cool. All right, let's see. There's negative infinity over here because I have an arrow on the left. That line, your axis of symmetry is at -6. And then you have an arrow on the right, so that goes to infinity, right? What is it doing from negative infinity to -6?
Going up.
It's going up. It's increasing. What's it doing from -6 to infinity?
Going down.
It's going down. It's decreasing. So there you go. You have your intervals. And what are my two end behaviors doing? Both are going down. Good. So they're both down to negative infinity. You have homework tonight. And what else is due next class? The take-home quiz. If anyone has one to turn in now, I will take it.